Hello, welcome back. We're working on physics free-fall motion problems. I'll be honest, this problem took me a minute to figure out how to do. There's probably 1,000 ways to do this problem, so when you do it yourself, play around with it. You'll probably find a more elegant way or a different way that's totally fine. I'll show you the way I did it to give you some things to think about. So we have two rocks are thrown up, straight up, one with 3 times the speed of the other one. Two questions. If the faster stone takes 10 seconds to hit the ground, how long did it take the slower rock? Okay, that's part A. Part B, if the slower rock reaches a height h, how high will the faster rock reach in terms of h? In other words, if the slower rock reaches h, height, then we know the faster rock is going to go much higher. How many times higher than this guy is it? So is it 5 times h or 10 times h higher, or is it 3 times higher because we threw it 3 times faster? Or what is the deal? So this is interesting because there aren't too many numbers in the problem, and that's what makes it a little bit more challenging. So you got to really draw some pictures and think about it. So one more time, we're throwing two rocks straight up. We throw one of them with a certain velocity v, and then we throw the other one with 3 times that velocity, so 3 times harder, for lack of a better word. And the first part, if the faster stone takes 10 seconds to hit the ground, how long does it take the slower stone? So we have to draw a picture of both of these rocks making their travel, and honestly, it's very difficult to figure out what to do in this problem until you get something written down. So here we have the ground, right? And we have 2 rocks that are being thrown, so we need to draw both of them. We have the first rock that's going to go up and then come down. And actually, I already kind of screwed up with what I wanted to draw. The first one comes up, let's call it maybe this high. And then the next rock, we're throwing it 3 times faster as an initial velocity. So I don't know how high it's going to go, but I know it's going to go higher. I don't know if it's going to go 3 times higher because I'm throwing it 3 times faster, if it's going to go some different amount, but we know it's going to go higher. Now again, you need to keep in mind that this is a one-dimensional motion. The rocks are going straight up and straight down. I have to draw them as an arc so that we're not drawing right on top of the same lines, but this is really straight up and straight down motion type problem. All right, let's write down what we know. It says if the faster, so we have to first of all label some things. We're going to draw, this is going to be called the slow rock, and this is going to be called the fast rock. Why? Because in the problem it says 2 rocks are thrown, one with 3 times the speed of the other. It does not give us the initial velocity. And that is one thing that's going to trip up most people doing this problem. Because you think, well, you have to have all the numbers in order to do anything. But I didn't give you the initial velocity. But what I did tell you is that these 2 rocks are joined together because one of them has a 3 times the initial velocity. So you don't know what it is, but you know that if this rock has an initial velocity of v naught, I don't know what it is, then that means that this guy must have an initial velocity of 3 times v naught. Very, very important. In fact, I'm going to go so far as to say that if you know to write this down here based on the problem statement, then you're probably 25% of the way to solving the problem. You don't know if it's going up at 10 meters a second or 12 meters a second or whatever, but you know that however fast I throw the slow rock, that's why we call it the slow rock, because it's only going this fast, then this one is thrown 3 times as fast. That's why it's called the fast rock. So we know that whatever speed this is, we're going to denote it as v naught, and then 3 times that amount is going to be however fast that's traveling. All right? What else do we know? We know that we know that the initial position of the rock is 0. We're calling ground level 0, which will be the same as true over here. So we can say that the initial position of the rock is 0 right here. What else do we know? We know that the only thing acting after it leaves my hand is gravity, which is negative 9.8 meters per second squared. And of course, the acceleration here is negative 9.8. I'm not going to put the units because it'll clutter it, but it's meters per second squared. What else do we know? Anytime you throw something, you know something about the top. When you get to the top, you know the velocity is equal to 0 because it turns around as it stops and comes back down. And so at the very tippy top, you know the velocity here is at 0. So we're literally trying to write down everything that we know. We read the problem again. 2 rocks are thrown up, one with 3 times the speed of the other. We have that. If the faster stone takes 10 seconds to hit the ground, how long does it take the slower stone? That's something we need to find. So we have the slow rock and the fast rock, the one we're throwing harder. So I'm going to put a little arrow here, and I'm going to say the time is 10 seconds to hit ground. Now, there's many ways to do this problem. What I did is